Hey guys. So yesterday we had a chance to do day 4. It was a mini day. We talked about congruent triangles. And so obviously you guys had page 2 for homework. And I just wanted to briefly make sure that we were good on these. So remember, we're given that these triangles are all congruent. And we want to say what line segment or what angle would also match up and be corresponding. So for example, FD, bada boom, right here. Well, that's got the 3 tick marks. We know that's going to line up with KI or IK. We'll go with IK. Line segment IK. Then we've got angle A with its two ticks. That's going to be with M with its 2. So angle M. Then you've got another angle, U. Sorry. Well, we know U is across from these 3. So I'm going to put 3 rings because it opens up to that side. Well, that must mean F opens up to this. 3 rings. Bada boom. So angle F. Beautiful. And then finally, last angle here, WVU, West Virginia University. And GHI, so if it's W to V, I'm going to make that 1 tick. V to U, I'm going to make that 2 ticks. And then obviously U back to W, I'm going to make that 3 ticks. And we follow the same pattern here. Check it out. G is where W was, so we start with G. We go to H. G to H is 1. H to I is 2. And then obviously I back to G would be 3. And so we look and we say, okay, W opens up to this side. That must mean that, G is going to open up to that side. And again, they are the same letter here, the same first letter. So that makes it a little easy too. And so guys, before we get into day 5, I just wanted to do a quick reminder about solving systems. It seems like there's a couple of us maybe that are still struggling a little bit. And I mentioned yesterday that we're going to be using substitution to solve both of these. And again, the way we know to use substitution is if a variable is by itself. If you have a variable by itself, you're using substitution. Well, check out number 1. Here's our variable y by itself. We know y equals negative x plus 2. Well, if y equals negative x plus 2, that must mean this other y, which is the same exact variable, would be negative x plus 2. So we substitute 3x plus 3, and then watch the parentheses here. Yep, because it's going to be 3 times y, and y is multiple things. Negative x plus 2 equals negative 3. That's a lot of 3's. My least favorite number. Redistributes 3x. 3 times negative x would be negative 3x. 3 times 2 gives us 6 equals negative 3. And this is going to be interesting. 3x and negative 3x, those subtract out. They subtract with each other and cancel, and you're left with 6 equals negative 3. Well, that's not a normal solution. Oh, is this true? No, this is not true. So this is not one solution or infinitely many. This is no solution. In other words, these two lines are parallel. We got some parallel lines here. They will never intersect. So that's no solution. And then very quickly, you guys, I'm going to give you a chance. Take some time to try this one real quick if you haven't already. Hopefully you have, but we'll check it here in just a sec. All right, so you work this out. You see, hey, y is already by itself, so we can plug that in for y. We work it out, and we get 4 equals 4. Hey, that is true, which means these two lines, if you were to add the 3x over, these two lines are the exact same. They're the same line, so they are infinitely They have infinitely many solutions. In other words, line 1 and line 2 are on top of each other. They're going to intersect at every single point forever. All right, so now on to day 5. So to day 5, guys. And before we get started, couple reminders. We have our Chapter 5 quiz. It's going to be posted today. So our Chapter 5 quiz is going to go up today. Also, make sure you are working on Delta Math. Our Delta for this chapter has also been posted. So those are our 2 big housekeeping items to start. 2 things there. And now into what I think is a pretty neat day. There is going to be no math, no algebra. Check this out. No algebra today. This is all going to be pure concept, and I think you guys are going to have some fun with it. There are going to be some jokes that make themselves here. We're going to be dealing with postulates that involve congruent triangles. So if you remember on day 4, we introduced the idea of congruent triangles, how congruent triangles have similarities. They're the same triangles. That's what day 4 was all about. So here on day 5, we're going to talk about a little bit more specifics here. We're going to be involving some postulates, which we will get into. You're probably wondering, wait, SSS, SAS, ASA, AAS, what is all that? I've never really seen that before. And also we're going to be talking about how CPCTC, corresponding parts of a triangle, are congruent. We're going to use that to solve some problems here. That'll be more during our homework, though. But real quick, guys, let's talk about something that may sound a little confusing until I use another word to describe it. Check this out. Included angles and sides. You're probably thinking, wait, included angles and sides. What's that about? So angle A is the included angle for AB. Notice I'm in a color code. That's blue. This is blue. AB and AC. Okay. Angle B is the included angle for BA and BC. Oh, I'm starting to get the picture. Angle C is the included angle for CA and CB. In other words, when we say included, we mean between. Angle A is between AB and AC. Angle B is between BA and BC. It's like the axis of it. And angle C is between CA and CB. And the same goes for sides, guys. AB, line segment AB. I'll do it this way. Line segment AB is between angle A and angle B. We're about to get real messy. BC is the included side, so BC for B and C. In other words, this side is between B and C. And then look at this. This looks like me whenever I try to do an art project. AC, the lightest sine segment, is going to be between angle A and angle C. That's all that means there, guys. So check it out. So EF is included between, so here's EF down here. Looks like it's included between angle, I would say angle 1 and angle 2. See that? Here's EF. Angle 1's on this side, angle 2's on this side. That's kind of what borders that side. And so I'm going to let you guys, I don't think you'll have too many problems. Try numbers 1 and 2 for me. See if you can write out what the 2 included angles are up here and the 2 included sides are down here. Go ahead. Let's see how you guys did. DE is between 1 and 3. DF is between 3 and 2. Angle 3 is included between DE and DF. Angle 1 is included between ED and EF. and angle 2 is included between EF and FD, or DF. Pretty straightforward, guys. And actually, what we're going to be talking about next as you flip over is also going to be pretty straightforward, but it can be a little bit tricky for those of us who maybe aren't great with spatial recognition, kind of like me. So this is going to be the big postulate of the day. This is going to be the main topic, if you will. This is going to follow us for a little bit too. It's going to follow us through most of the rest of this chapter. So guys, these are ways, check this out. This postulate, ways we prove triangles are congruent. So if we're going to prove that triangles are congruent, that this triangle and this triangle are the same, if we're going to prove that these are the same, we have some postulates that we can use to prove it. So for example, side, side, side congruency. If three sides of one triangle are congruent to three sides of another triangle, then they are congruent. So three sides, check this one out. If two sides and the included angle, side, angle, side, in that order, remember, order matters, are congruent, then the triangles are congruent. So check it out. Side, angle, side. Sass, a little sassy. Side, angle, side. See that? That's what we're talking about right there. How about ASA? Angle, side, angle. Remember, order matters. If two angles and their included side between them, so we've got angle, side, angle, angle, side, angle. We see that there. Yep. Then, of course, the triangles are congruent. And then finally, we've got AAS. So again, order matters. I can't stress that enough. Angle, angle, side. So two angles and the non-included side. So back-to-back angles, check it out. Angle, angle, side, angle, angle, side. You see how there's no side in the middle that's congruent? That's what we're talking about. Because that would be this up here. Angle, side, angle, or angle, angle, side. So those are the 4 ways to prove. And I already can hear the jokes. I can hear them now. What about angle, side, side? No, that is not a way to prove. And in fact, you know what they say about assuming that could be a way to prove triangles. So yeah, that's not a way that works. It's just these 4. So let's get some practice in, guys. Let's switch over. This is page 3. So remember our 4 kinds here. We've got side, 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 angle, side, angle, side, angle, and angle, angle, side. Remember, those are our 4 options here. 4 possible ways we can prove this. So let's check it out. So starting off, it looks like we've got side, angle. Okay, checks out here. Side, angle. Wait, where's our other piece? Oh, they share the same leg. Side. Yeah, this side belongs to both triangles. So side, angle, side, side, angle, side. SAS. Perfect. And that's all we're doing here, guys. That is all we're doing here. Check it out. So this one looks like we've got a side, we've got an angle, we've got a side, we've got an angle. But it doesn't look like this side's congruent. So it's not SAS. We don't have SAS. Is this angle congruent with this angle? No. So we don't have that. This is no. We can't determine whether these triangles are congruent. We don't have a third piece. And we can't jump and say this is, because then you'd be saying side, angle, skip a side, skip an angle, side. You can't do that. You can't skip like that. So nope. And this is the key, missing third attached piece. The pieces have to be kind of attached here. You can't go from this angle, skip a whole leg, skip a whole angle, and then jump to this side. You can't do that. Let's try number 3. Okay, we've got a side. Ooh, the problem is there's nothing else here. We don't have this angle, we don't have this side, we don't have this angle, we don't have this side, so that is no. How about this one? Okay, looks like we've got an angle, we've got a side, got an angle, got a side. I don't see a third piece, but wait, these are vertical angles. That means this and this are congruent. So hey, ASA. And what I'm going to do is I'm going to let you guys see if you can try. We're going to try 5 through 10. We got 6 problems to try here, guys. See what you can do on 5, 6, 7, 8, 9, and 10. All right. So first one, we got angle, angle, side, angle, angle, side. Number 6, side, side. Hey, they share this same piece right here. So side, 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 side. Number 7, side, angle, side. Side, angle, side. We see that there. Number 8, angle, side, angle. Angle, side, angle. Number 9, angle, angle, side. Angle, angle, side. See that there. And then number 10, we've got, I think another one, angle, angle, side. Angle, angle, side. Yep. So hopefully you guys absolutely crushed that. So those are ways we prove triangles are congruent. And so as we flip to the last page, I just want to look at a couple tough ones. Tougher, I'll say. Let's look at a couple tougher ones together before we close. We're almost finished. So I thought I would let you guys try just these 3 on the right side here. See if you can try 12, 14, and 16 for me. Let's see what you end up getting here. As far as, remember our 4, we've got AAS, SSS, SAS, and ASA. Go ahead and give it your best shot. Okay, number 12. We've got 2 sides, and it looks like, they share a third side. So side, side, side. Number 14, we've got angles on both sides here. Problem is, that's just 2 pieces. But wait, in the middle, check it out. They share a side, so angle, side, angle. A saw. As some people used to say. That was always the running joke in geometry. A saw, dude. I apologize. And then we've got a side and a side. Oh, and then they share a side in the middle. But the problem is, that's just 2 sides. We don't know about this side or this side. And we don't know about the angles. So that's a no. We don't know the congruency there. All right. And so, guys, as we finish, don't forget about a couple things here. Your homework. We're going to have a Google form over day 5 practice multiple choice. There's going to be a Google form over that. Don't forget about our quiz. We got chapter 5 quiz. And then don't forget about your delta. 3 big things here, guys. Hope you have a great weekend, and I'll be talking to you soon.